Morning, students. Yesterday we have studied about the remainder theorem, and the remainder theorem states that is a value of p of a gives us the remainder. Today we are going to study factor theorem. Now factor theorem states that if p of x is any polynomial of a degree greater than or equals to 1 and a is any real number, and if p of a is 0, it indicates x minus a is a factor of p of x. So if you get the value of p of a is 0, then we can say that x minus a is a factor. And if we know that x minus a is a factor, then the value of p of a will be always 0. Now we will solve certain sums to understand this. Determine which of the following polynomial has x plus 1 as a factor. Now as x plus 1 is a factor to be checked. So first we'll compare that equal to 0 and we get the value of x as minus 1. The p of x is given x cube plus x square plus x plus 1. Now we will calculate the value of p of minus 1. Now we know how to calculate p of minus 1. Just replace x by minus 1. And when we simplify, minus 1 cube will become minus 1. Here it is a plus 1, minus 1 and plus 1. So ultimately we get it as a 0. Now since p of minus 1 is 0, it indicated that x plus 1 is a factor of p of x. Now another question. They have given p of x as x cube minus x square minus 2 plus root 2x plus root 2. Same way we have to check for the x plus 1 as a factor. So we'll replace x as minus 1 and we will calculate p of minus 1. When we calculate, this will be minus 1 cube will becomes a minus 1. Minus 1 square is a plus 1, but minus of plus 1. So ultimately it will becomes a minus 1. Here this is a minus and here is also minus. So when we multiply, minus of minus will becomes a plus. It means we have to multiply it by 1 to this bracket. So that will remain as it is. We get 2 plus root 2 and plus root 2. Naturally, when we simplify, we get it as a 2 root 2. Since p of minus 1 is not 0, we will say that x plus 1 is not a factor of given polynomial p of x. Now we'll solve more sums. Here they have given that use the factor theorem to determine whether the g of x is a factor of p of x. So g of x is another function, p of x is a one function. Naturally, g of x will be the linear function. Here they have given p of x is x cube plus 3x square plus 3x plus 1 and g of x is given x plus 2. To check g of x is a factor or not, first we'll compare x plus 2. That is, a g of x is 0. So x plus 2 is 0. From that we get the value of x as minus 2. We will calculate now p of minus 2. So first write p of x. Now we'll write p of minus 2. Now to calculate p of minus 2, replace x by minus 2. So what we get? Minus 2 cube will be minus 8. Minus 2 square is plus 4. 4 3s are 12. This is a plus into minus. It becomes a minus 6 plus 1. And when we simplify, we get it as a minus 1. So we get p of minus 2 is not 0. And it indicates that x plus 2 is not a factor and x plus 2 was our g of x. So we will say that g of x is not the factor of a given p of x. Now we'll take one more. Here they have given the p of x as x cube minus 4x square plus x plus 6 while g of x is given as x minus 3. Now to check g of x is a factor or not, first g of x should be equal to 0. So it indicates x minus 3 is 0, or the value of x we get it as a 3. Now we will calculate p of 3, and for that first we'll write p of x, then we will write p of 3. Now for p of 3, replace x as 3, and after simplify what we get? 3 cube is 27, 3 square is 9, 9 fours are 36. So it will become a minus 36 plus 3 plus 6, and we get it as a 0. So we get p of 3 is 0. Since p of 3 is 0, x minus 3 is a factor of p of x, and x minus 3 was our g of x. So we'll say g of x is the factor of p of x. Here we have checked whether it is a factor or not, and for that we are checking with the p of a, and whenever we get 0 we say yes, it is a factor. Now in the next sum they have given that it is a factor, and they have asked to find out the k. So find the value of k if x minus 1 is a factor of given polynomial p of x. Here the p of x is given as 2x square plus kx plus root 2. Now as they have stated x minus 1 is a factor, we can say that p of 1 will be 0. As they have given x minus 1 is a factor, so by factor theorem we get p of 1 will be equal to 0. Now first we'll calculate p of 1. For that first write p of x. Now to calculate p of 1, replace every x by 1. And when we simplify, what we get? 1 square is 1 into 2, that is a 2, plus this is k plus root 2. This is the value of p of 1. Now p of 1 is 0. So that will indicate it as 2 plus k plus root 2 is equal to 0. And so the value of k will be, this plus 2 shift on the other side will becomes a minus 2 minus root 2. We'll take one more sum. P of x is given kx square minus root 2x plus 1. Here again they have stated x minus 1 is a factor. So by factor theorem, what it indicates? P of 1 will be 0. Now calculate P of 1. Now P of 1, it means every x should be replaced by 1. So what we get? 1 square is 1. 1 into k is k. This is a minus root 2 plus 1. Now as p of 1 is 0, this value, that is a k minus root 2 plus 1 is equal to 0. And from that we get the value of k as this minus root 2 will shift on the other side, will become plus root 2, and this is minus 1. So we get the value of k as root 2 minus 1. Hope you have understood what is a factor theorem. The factor theorem states that if we know that it is a factor, then p of a will be 0. And to check, we will check p of a, and if we get p of a as 0, we say yes, it is a factor. And so you can solve the remaining sums of these questions, and hope you can solve it. Thank you, students.